Alrighty, here are the video notes for section 10.2. We'll be talking about a special type of triangle called a 45, 45, 90 triangle. It's called a 45, 45, 90 triangle because the degrees in this triangle, there's one 90-degree angle, and the other two angles are both 45 degrees. Since both of these two angles are exactly the same, and the other angle is a right angle, this is an isosceles triangle, and therefore the legs are also the same. So the two shorter legs and the two angles are both congruent. The ratio of the lengths of the sides in a 45, 45, 90 triangle will always be the same. So if you look here at our 45, 45, 90 triangle theorem, we see the standard 45, 45, 90 triangle with side lengths of 1 and 1 and a hypotenuse length of square root of 2. So if we scaled this triangle up and multiplied everything by, let's say, 6, if we multiplied each leg by 6, then we would also multiply the hypotenuse by 6, and we would get side lengths of 6, 6, and 6 root 2. So we can use this ratio of the sides to find the side lengths of any 45, 45, 90 triangle. So let's use this ratio in example number 1. It asks us to find the hypotenuse of the given 45, 45, 90 triangle. So we're given, since one angle is 90 and the other angle is 45, if we add those up and subtract them from 80, we see that this angle also has to be 45 degrees. So the ratio will be the same. So if we draw our standard, or look at our standard 45, 45, 90 triangle, the shorter side of a standard is 1, which in this triangle, the shorter side here is 3. So to find the new hypotenuse of this 45, 45 triangle, I'm going to call it x. I will put the length of my original triangle, which was root 2, compared to the hypotenuse length of my new triangle. So I set up a ratio where I put the original, or the standard 45, 45, 90 triangle lengths on top, and my new triangle lengths on bottom. Now I need to cross multiply, and I can find the value for x, the hypotenuse of my new triangle. So if I cross multiply, 1 times x gives me x, 3 times root 2 gives me 3 root 2. So x equals 3 root 2. Let's look at example number 2. Find the length x of each leg in the given 45, 45, 90 triangle. So again, we have our triangle. We know that one angle is 90, the other two are 45, so it will fit the ratio. So if we set up the ratio of, we know that a standard 45, 45, 90 triangle has side lengths of 1 and a hypotenuse length of root 2. In our new triangle, we have side lengths of x, that's what we're trying to find, and a hypotenuse length of 7 root 2. So we can set these equal to each other, and we cross multiply. So you get 1 times 7 root 2 gives us 7 root 2, and root 2 times x gives us x root 2. Since we have a root 2 in both sides, we can divide each of these by the square root of 2, which would give us that x just equals 7. Alright, let's look at example number 3. It says to determine whether there is enough information to conclude that the triangle is a 45, 45, 90 triangle, and explain our reasoning. So we're given a picture of a triangle, and we know that one angle is a right angle, so it's 90 degrees. And the other two angles we know are the same, but we don't know what they are. So let's figure out what x, the angle measure of those angles, are. Well, again, we know that if we add up all three angles, there are 180 degrees in a triangle. So we have x plus 90 equals 180. If we subtract 90 from both sides, we get that x plus x equals 90, or 2 times x equals 90. If we divide both of these sides by 2, we get that x is equal to 45. Therefore, both of these angles must be 45 degrees. So this is a 45, 45, 90 triangle. So if we are given a triangle with a right angle and the other two are exactly the same, it must be a 45, 45, 90 triangle. All right, you're responsible for checkpoints numbers 1 through 4.